Good afternoon. Welcome to another edition, 2017, at Devoxx, Belgium, of Ask the JDK Architects. This is the shortest presentation of the week. Don't believe a word that we say.
This guy's missing too. Oh, okay.
Right. Not necessarily in order yet. Like I said, don't believe a word we say. And this is Q&A. There's a microphone over there, or no, there's a microphone there. I don't see one over there. It would be best if you would use the microphone. That way the recording will make sense and we don't have to repeat your question. If we repeat your question, we will almost certainly distort it, and that would be bad. Bad for you, not bad for us. Or just a moment. Or you can ask questions by tweeting this hashtag. But first, we will each introduce ourselves, starting with Alan.
Alan Bateman.
Brian Goetz. Stuart Marks. I work with Alan Bateman on the JDK core libraries, and my alter ego is Dr. Deprecator.
Well, actually, you are Dr. Deprecator. Your alter ego is Stuart Marks. Yeah. My name is Alex Buckley. I work on the Java language and VM specs.
And my name is Mark Reinhold. But you knew that. All right. Who would like to ask the first question? No questions? Okay, we're done. Their microphone in the back, please. Or, well, halfway up. It's the first session after lunch, an opportunity for exercise.
It's like a reverse the Price is Right. You walk towards the back.
Exactly.
All right.
Come on up.
So there are many new projects going on to improve the JDK. Under very nice code names. My favorite, that I haven't heard much about lately, is Project Sumatra, which would make it possible to make use of the power of GPUs and other heterogeneous architectures from within Java. I know there's some external frameworks, but I was wondering, what is the state of introducing that in Java itself?
So Project Sumatra was jointly funded by Oracle and AMD originally, and after about 2 or 3 years, it kind of fizzled out. The results that we were seeing in terms of performance were not very compelling, and the resources that were involved in it kind of went and worked on other things. And so it's been dormant for quite a while. But the logical follow-on to Project Sumatra is Project Metropolis, which is the an umbrella project for a wide range of Java on Java technologies, replacing various components of the JVM with components that are written in Java. And sort of the biggest component of that is looking at the Graal compiler developed by Oracle Labs as a possible replacement for the C2 compiler. And Graal has a fairly nice story for generating GPU code. So it looks like the most promising path to getting automated vectorization and automated GPU targeting in Java would be through that. Secondarily, if you look at the recording of the Intel keynote at Java 1 this year, there's some demonstrations of some work of vectorization that's being done in the compiler backend, in the JDK, targeting the AVX instruction set. So it's not just GPUs, but also the vector instructions that are available in modern 64-bit CPUs as well.
It was always an unfair question, but any idea on what the timetable is the roadmap is to expect that in?
Sometime between now and the heat death of the universe.
Thank you. That was very useful. No, seriously, thank you.
Question about Project Amber. Pattern matching is super cool. I'm wondering though, in the example you showed about different shapes, aren't you kind of forcing people to stop using object-oriented programming? What's your opinion?
So this is a great question, so I'm glad you asked that. So object-oriented programming, in particular inheritance, gives us a form of declaration site polymorphism, which is to say that when you're designing your class hierarchy, you can specify a polymorphic implementation of an operation like the shape area one that I gave. That's a good tool to have in your toolbox, but that is not necessarily the only sensible way to use polymorphism. Pattern matching complements this by giving you use site polymorphism or ad hoc polymorphism, where you can say, here's an operation that operates on an ad hoc collection of targets. Maybe they're related by a type hierarchy like shape, maybe they're not. The operation I'm performing is not necessarily one that's so important that it belongs in the type hierarchy, and so it makes more sense to implement it in an ad hoc polymorphic way. And there are situations where that's absolutely the right answer. So if you think about the kind of things that we do with the visitor pattern today, where you have, the classic example from the Gang of Four book is the data structure you're groveling over is a document in a word processor, and you have some operation like count the words or change all the bold words to italic or something like that. Some of those make sense to put in the hierarchy of your node classes, and they belong in the domain, and so you would use inheritance for that. Some of them, like count the number of occurrences of the string 42, obviously would be a stupid thing to put in your hierarchy. You'd have like 16,000 methods, and so you don't want to use inheritance to define those things. So pattern matching complements the polymorphism that we get with inheritance, and lets you as the programmer choose between, is this a sensible thing to do as part of my object hierarchy, or is this a sensible thing to do as the use site? And having both tools, you have a better chance of picking the right one.
Cool, thanks. One more, it's the same subject. Using the var instead of the variable type declaration. It's easy for the computer to interpret it, but for the user, you're kind of missing some information at a glance.
It's actually could be the other way around. There's a lot of work for the computer to do that as well, including some difficult choices that the computer has to make that we try our best to hide from you. But ignoring that, when we design language features, everyone says they want less boilerplate, but that's not really what they want. What we want is for code to be more readable. So is deleting the type information or including the manifest type information, which is more readable? And the answer is it depends on the code. So there are times when the type information is just in the way, it's just obfuscatory, and by removing it, you can see what's going on more clearly. And there are times when the type information is very helpful, especially when you've chosen rotten variable names like X, Y, and Z, and you take that type information away and you've lost, you've lost something. So again, it's one of those things where developers have to use their judgment as to what constitutes more clear, readable, maintainable code. We think that this is a tool that's reasonable to have in the toolbox. Will it be misused? Absolutely. No question it will not be misused. Is that a reason to say no one should ever get to program this way because some bozo might ruin it for the rest of us? That seemed a little mean. So it's, I think good developers will use this tool effectively and write better code. Bad developers will use it poorly and write worse code, but it's not like buying insurance against bad code is very easy to do anyway. So on balance, it seems like an improvement.
Okay, thanks.
So as a complement to that, so Brian, of course, said it's going to be misused. There's no question about that. But the flip side of that is whenever there's a new language feature, it takes time for developers to learn how to use it effectively. And so one of the things that we've been discussing internally is developing a style guide for this, right? So, and you see some of this in the surveys and the write-ups that Brian has put out, but sort of you can imagine a whole bunch of rules that emerge about this, but I think the overarching rule is use the var construct when it makes the code clearer and more concise and you're not losing essential information. It's a little too easy for somebody to say, don't use var because it doesn't have the type information. Well, if you've chosen the right variable names, if the initializer makes it clear, then you don't necessarily need the explicit type there, and that depends on the context. And so I think developing some style rules about that, about how to use this new construct effectively, is something that we're keeping an eye on, and we might put out some articles about that at some point.
It's quite interesting that in a lambda expression, you can omit the type of the lambda parameters, and no one's very worried about that. And yet that's a place where obviously it's more compact. You typically have multiple variables, and you don't have as much space as you do when declaring locals. So obviously you want to elide as much as possible, but that puts then the focus on what are the parameter names for this lambda. And then then you get into the body of the lambda and no one is worried that you didn't have an explicit type for the lambda parameter. So I think a lot of that in practice will carry over to local variables declared with var. Because bear in mind, it's just local variables. It's not fields. It's not formal parameters of methods. So the next question is going to be, can I use var for lambda formal parameters? The answer is yes, right?
One more thing I want to add to it is it's very easy to imagine, I have some code now, if I change it to use this feature, it will look worse if I put var here. But we don't always realize the way we distort code to fit into the language as we have it. So I see a lot of code where people have crammed everything into one either chained expression or deeply nested expression because apparently they didn't want to have to declare a variable. By lowering the ceremony of declaring a variable, there's a chance that people will actually separate these things that are logically separate things into their own variable with an assignment and make the code more clear. So I think there's a degree to which people are distorting their code today as a workaround for the verbosity of having to declare not only the variable but the type, and sometimes the types are fairly long to write out. And if they don't have to do that, they may actually write better structured, simpler code.
Okay. Have we exhausted this one? It's a very, very rich topic. So there's a question from Twitter I'd like to take. Why two big heap GCs, both Shenandoah and Zed GC? So for those of you who don't know, some engineers from Red Hat have been working in the OpenJDK community for a while now on a garbage collector designed for large heaps and low latency. It's called Shenandoah. Recently, some engineers from Oracle announced the intention to, they proposed to create a new project in OpenJDK for a similar garbage collector, but a different garbage collector, which, for reasons not up to us, were developed internally at, this GC was developed internally at Oracle for a while, and it's not mature either. But it's coming along, and as part of the general move towards open sourcing all of the commercial features in the Oracle JDK, ZGC is one of those components, and so that's why this proposal was made at this time. This is just about source code and projects at this point, right? Neither of these GCs is in the JDK mainline. Maybe one of them. Maybe both of them ultimately will be in the JDK mainline. It's up to everybody working in the OpenJDK community to figure out what makes sense. Maybe each GC has, maybe there's enough difference between the problem spaces that the GCs address that it does make sense to have them both. Maybe there's some way to unify them to get the best of each and have everybody with this expertise in the OpenJDK community work on just one garbage collector that winds up in the main line. We don't know yet, okay? It's just a proposal for a project. We'll have to see what happens. Please.
Yeah, so I have the honor to be the first one to ask question on JDK versions.
What, Alexi would like to add something? Okay, special guest, Alexis Avila.
Hey, I'm actually the guy who develops Shenandoah, among other things. And none of you guys develop ZGC, so it's easy. So you might think it is problematic to have two proposals on the table, but the thing you don't realize without studying the GC code like that is that most of the parts that are interesting for users are not the GC algorithm itself, but rather the runtime improvements that come with it. Because runtime has to do many things like weak reference processing that it has to do concurrently for concurrent GC to work, and all this language-specific stuff. So having two proposals basically means that you have twice as many people working on these shared parts. So as Mark says, whether or not one GC is overwhelmingly better than the other, it's the open question, and what will we do to when a time will come to decide which GC goes in or whether both GCs are going in. By that time, we will also solve lots of problems and we will merge some of the good solutions from both GCs. So everybody in this room will totally win.
Thanks, Alexei. Okay, anybody else? Or okay,
Yeah.
let's go ahead.
So I've got a question concerning JDK versions. Part of the current statement is that bytecode version will increment with every feature release. And aren't you worried the impact it might have on all the bytecode processing libraries that are literally instrumental to all the frameworks we users are building upon?
A little bit. But you know, this is a big change, you know, not just for those of us who work on the JDK, but people who maintain things built on top of it, especially things like bytecode libraries that are, you know, that sometimes get fairly intimate and need to know what the class file version is. But the way I look at this is all the reasons that say that it makes sense to increment the first numeral of the version number, going from 9 to 10 to 11 to 12 and so forth. All of those are the reasons that say that makes sense to do that on a time-bound basis. Same thing applies to the class file version number. All of the same reasoning applies. So if you accept one, then I think you have to accept the other. I understand. You know, we understand it will be tricky, at least at first, for tools and libraries that are sensitive to the class file version to adjust to this at a quick pace. And maybe in some cases, at least, they can find more flexible ways of doing that rather than baking in specific version numbers. But a sort of philosophical point about all this and something that I think colors the way that many of us think about it is doing a major release as we have every 2 to 3 years with a schedule that can adjust is really painful. And doing these big releases is really painful. A lot of that pain, you know, there's this generic truism about a painful process. If a process is painful, do it more often, and you'll be forced to figure out how to make it less painful. And I suspect that applies in this case too.
One other thing to say as well is that the most popular bytecode library out there is ASM today, and the committers on ASM are actually working on all of these projects that are actually changing the bytecode. So you can be confident that the day that a new version goes out, there will be, same day, you would hope, a version of ASM that actually supports that. Yes, there'll be a stack of other tools and plugins that will need to possibly update their dependencies, but the most popular bytecode library should actually be supporting the version on the day it ships.
Here is a small anecdote that echoes Mark's point about doing something faster to get the most out of it. I remember vividly after Java SE 7 went final. So SE 7 was the release that had Invoke Dynamic, the Invoke Dynamic bytecode in it, and a whole bunch of new class file stuff. There was a new class file version, 51 for SE 7, great. A couple of years later, I got an email, and it was someone saying that a well-known tool that I shall not name was being tripped up by one of the new constant pool, new kinds of constant pool entry. And I thought, but we added that 2 years ago. It was perfectly well specified, it was clearly documented, but that tool hadn't yet gained support for version 51 class files 2 years hence. For some people, there is no amount of slowdown that's enough. For some tools, there is no amount of waiting and hang on and I'm not ready yet that's enough. So at some point, whether it's there's a release every week, month, 6 months, year, you have to accept the future and quit complaining that what's in this class file I don't understand. Well, it's 2 years old already. Rant over.
End of rant.
I can add to that rant in that I saw a bug report yesterday where someone was complaining about a bytecode library that was having trouble with constant pool tag 18 invoke dynamic. So the only reason they were seeing it now is because it was the first time that they'd actually use it with code that was compiled for with the new string concat. They probably have never tested it with lambda, but yes, you're exactly right. Years on, they're still finding problems. 10 years.
10 years.
Okay, next.
Okay, so I have a question about type inference, about the choice of the var keyword there, because like C++ and D have auto, and JavaScript has var, but a very different meaning, and we're not supposed to use that anymore anyway. And Groovy has def, which also has a different meaning, but it's used in the same type of context. So I was wondering what the choice was.
So you're wondering on what basis we made the choice?
Right.
Well, we wrote them all on the wall. We threw darts, and wherever it landed, that was good.
That's how we all make all the.
Yeah. The reality is, in some sense, these decisions don't matter, right? And that doesn't mean that we don't spend any time with them. In fact, we spend a lot of time thinking about them. But if we pick var, people say, "Why didn't you say def?" If we pick def, people say, "Why didn't you pick var?" We solicited some input through some user surveys. We had over 2,500 responses to a SurveyMonkey survey we put out, where we asked the same questions in like several different ways to try to elicit people's emotional reactions to various options. We looked at the data, we looked at our anecdotal evidence from focus groups, and we said, this is the one that feels most in the spirit of what Java developers are going to expect. And it's a subjective choice. I suspect that, like I said, if we had gone a different way, we would have gotten all the same questions of why didn't you do it the other way. It's just, you make the best decision you can. With the information you have, we gathered quite a lot of information. We made a decision.
Right. So in the end, it was a democratic vote.
It wasn't a democratic vote, but it wasn't an arbitrary, I like this best either. It was, we asked people what they thought. We listened to their answers. We thought about it ourselves. We asked each other, what do you think? And eventually we came to this seems like a pretty good answer.
Thank you.
Hi. Running Java inside containers still feels a bit more bulky than native processes. And things improve, but I would like to know what is ahead for us.
Sorry, when we're saying containers, do you mean
like Docker containers?
Docker containers.
Yes, yes. So especially in regard to initial resource usage and making resource usage transparent to the outside world, like Kubernetes and resource limits and so on.
Right, so there's some good work going on in this. One of the 8 updates and in 9 both have XX options that you can actually turn on to pick up the resources and memories available when you're running in C groups. Bob Van Det has another JEP, which there's some of the changes actually are going in review at the moment to go into, I guess, 10, that will really improve this as well. So if you go to the hotspot list, you'll actually see a big, long discussion that's going on over the last couple of weeks, trying to refine that so that the right information about the container environment can be used to actually to size memory.
Okay.
And thread pools.
Okay. Anything really exciting ahead as well? Oh, this is good enough, not to say. Yeah.
The best thing you can do on JDK 9, other than the XX flags, to what is it? Set the number of CPUs. Heap size, CPU. Yeah. Is the first thing you should do after you download JDK 9 is run JLink and build yourself an image which is just the Java base module. Okay. And you will find that any Docker image you then make is radically smaller than the one you were getting from JDK 8. Radically smaller.
Yeah, so that will save you on Docker image size. It's not as though it's going to start up 10 times faster or anything. But yeah.
There are a couple of projects going on the startup side, though, right? So container friendliness has a lot of aspects, as Alan pointed out. There's respecting the global limits that Docker tries to set. As Alex points out, there's container size. On the startup side, there's a couple of projects going on, which is we're open sourcing app CDS, and also in 9 there's a sort of technology preview of ahead of time compilation, both of which are startup and sharing plays. And so if you're running either starting the same container over and over again or running the many copies of the same container on the same machine, they can share more data across VMs and therefore use less memory. So there's quite a few initiatives going on to make Java more container friendly, all going on sort of at their own rates.
I think it is a very good idea to have a 6 months long release to move Java forward faster. That's great. But my question is, ideally, if you could remove just one feature from the language because it doesn't play well with the rest, because it slows you down, which one will be?
Protected. I hate protected with a passion. It is so much more complicated than not just all of the other access control modifiers, because you said in the language, you were very specific about in the language, not in the platform. In the language, protected, it has impact at compile time, at verification time, at runtime, and obviously there is a particular kind of scenario where it is useful, which is very heavily oriented towards subclassing. But we all remember the effective Java recommendation to prefer, agglomeration, is that the word, over inheritance? Delegation over inheritance, which means composition, yeah, right, over inheritance. And so protected is, no, inheritance is the best thing ever, and I'm gonna have a little hierarchy, and you can access that bit, but not that bit, and you have to go through the right receiver. Really look up the rules for protected. It's awful. That's my answer.
This is one of Alex's regular rants. As maintainer of the language and virtual machine specifications, he's entitled to rant about things that make his life hard.
So I wanted to mention something that we've already started work on removing, which is, I will bend your question a little bit, so it's not officially part of the language, but it is part of the platform, and that feature is finalization. And so in JDK 9, we deprecated finalization. It is not deprecated for removal yet. We expect that there's going to be a long transition period before we can actually remove it, but we started work on that. And so if you follow the JDK mailing list, you'll find a bunch of change sets where people are discussing removal of finalization from various key classes in the core libraries. And so I think that's one of the steps we need to go through. We need to do a lot more assessment about how many applications and third-party libraries are using finalization. But we don't have a full roadmap for this yet, but what we want to do eventually is get to the point where we can actually turn off finalization, because we had some discussion about GC here before. That is, if we had a GC person on the panel, they would be ranting about finalization. And the official word from Alexei here in the front row says it totally sucks, and that's his well-considered technical evaluation. And I think most GC engineers would agree with that. Finalization just complicates everything. Just like Brian and I have complained about serialization, just complicates everything. Finalization is the thing that we've already started work on taking that out, but it's going to take a while.
Most of the GC guys would say that weak references should be gone, but they can settle just.
Yeah. Let's do finalization first. We'll get to weak references later. Speaking of serialization,
yes, Stuart sort of stole my thunder here, but serialization has got to be the worst mistake we ever made. It is an infinite source of security bugs. It makes it much harder to evolve the libraries, because sometimes you have to worry about not perturbing their serial form as well as their external API and their behavior. And it's something that makes every language feature harder to develop. So like when we did Lambda in Java 8, the number of hours we spent trying to figure out how to make Lambdas interact with serialization was well into the hundreds. And the best that we were able to do is something that didn't always completely suck. So it was a tremendous, it took a tremendous amount of time and effort to get a mediocre result, and it has interacted with virtually every feature we've ever done.
Oh, serialization's top of my list. I even wrote the JEP to remove it.
He did.
Mark will remember.
It's dated April 1st, 2012 or something. And then you withdrew it.
Someday.
We'll bring it back.
We will resurrect this.
Someday.
Soon.
So the question on Twitter I'd like to take actually from Gunnar. In which release will the default behavior for the deep reflection switch, also known as permit illegal access, change? So for those of you who don't know what the switch is about, in JDK 9, all implementations of Java SE 9, we chose to allow a certain amount of deep reflection into platform internals, at least platform internals that existed back in 8, in order to make it easier to migrate existing code to 9. The plan over some period of time is to tighten that up. So right now, you will, at a high level, the description is you will get a warning on the first illegal access to some JDK internal API, and the warning will tell you how to get more warnings about all the rest if you want, but that's all that will happen. In some future release, we will turn the knob one notch, and then you will get a warning every time it happens. And then some release after that, we will turn the knob another notch, and you won't get a warning. It just won't work. Because finally, we will have strong encapsulation of all of the JDK's internals. So it's an interesting question, and one that we grapple with. Alan and I were talking about this again just this morning. How quickly should we ramp that up? Should we turn the knob in 10 in March? Should we wait until September for 11? Should we wait until 3 LTS releases from now? It's a tough call, but I think in principle we reserve the right to take away something that's been deprecated for removal in the very next release, the very next feature release, even if it's only even though it's only 6 months away. But it's also critical that we apply judgment to removing things. And in this case, I think the right answer, based on what we've seen in terms of people encountering these warnings, people who are still catching up, people who actively maintain libraries, dealing with these warnings and moving their code forward along with the platform. Our sense right now is changing that default in September probably makes sense. So you would get a warning on every such incursion. And then we'll see how it goes. And maybe we turn off all illegal access a year after that. Maybe we turn it off 6 months after that. A lot of it's going to depend on the data that's available. And a related point is, if you maintain a library or a tool or framework that's using some old JDK internal API, and to get away from that, you need some new standard API, we can't provide it for you unless you tell us. So, please come to the appropriate OpenJDK mailing list and let us know if there's, some straightforward method or a class or two that would make it possible for you to move away from using an internal API, and we'll look into providing it, or maybe help you provide it yourself.
There are about 150 people in this room, and I would like to do a quick straw poll, if I may. Who here has downloaded and run JDK 9? Basically all the hands. Good. Okay. Who, when running JDK 9, has seen the illegal reflective access warning that we're talking about? Some hands. Definitely not a majority of the people running 9.
No, maybe a quarter.
And when you saw, my friends, the illegal access warning, and you saw the bit that said, please report this to the author of the class that's doing it, please put your hand up if you actually reported something. 4 hands, yes. They should get like a gold
prizes, we'll give you a prize.
Or something. Thank you. Does talking to yourself count? Yes. Thank you.
Next question here.
In the old days of Java 7, when we wanted to reference a method, we had to use strings and reflection. And Java 8 gave us relief from all these problems, but there's one spot left where we cannot use method references, and that's if we want to use it in an annotation. Is it planned to fix that?
Yes.
Thanks.
So the enabling factor that we needed to get to before we were able to do that, because we knew from the outset that that's something that people wanted to do with method references, is being able to represent them in the constant pool. So if you read very carefully in the Java language spec, and project yourself forward into the JVM spec, you'll see that all the things that you can put in an annotation can be represented natively in the class file constant pool. And we did not have a suitable native representation for a method reference in the constant pool until now. So we have a JEP that is currently chugging along very nicely called Constant Dynamic, which allows a more flexible range of things to be put in the constant pool. So that was an essential enabling technology in order to get to where you want to go. Then there's a bunch of additional work. There's the JVM spec work for how do we represent this in class file? That's a matter of specification. There is some work in the language spec and in the compiler to enable it so. But most of that is the proverbial simple matter of engineering. The hard part was how do we represent these things? And from a language evolution perspective, we think it makes sense for the things for which the language gives a linguistic literal form to be things that are, they almost overlap perfectly with the set of things that you would put in an annotation. So method references is, so the constant method references, static method references, constructor references, and unbound instance method references are the sensible candidates for doing there. Bound references and lambdas would not happen.
Okay. Question on Twitter that I think would be useful to answer and should be fairly quick. Can you tell something about the expected timeline for open sourcing the commercial JDK features? So there are several of them, and the timelines vary. It depends on the feature you're talking about. So the principal ones are application class data sharing, which Brian mentioned earlier. That's actually slated for 10. The JEP for that will be proposed to target pretty soon, and hopefully targeted pretty soon. We have a Java flight recorder and Java mission control. Those I don't think are, well, I'm pretty certain are not going to make 10. We would like those to be done within the next year, and people at Oracle are working on them actively. The fourth big one is the Zed garbage collector, which we just discussed. There's a project proposal open for that. If and when that project is created, then the source code will be there, and activity will ensue. There are a number of other differences between OpenJDK builds and Oracle JDK builds in terms of features. The remaining features are all tend to be really small potatoes, and most of them are pretty obscure, and are what is likely to happen to some of them is we will decide these are so obscure they don't belong in either kind of JDK. We're just going to get rid of it because it's maybe some old legacy thing that was done for some Sun product 15 years ago and just doesn't matter anymore. In some cases, there are things that we're pretty sure no one cares about, and it's code that we cannot open source, so we'd have to write it all from scratch. For example, SNMP support. How many people care about SNMP? Apparently it was a good idea 10 years ago, but it hasn't. Oh, one, okay. But it hasn't caught on, and we've got this body of code that we just don't have the rights to open source. So if somebody wants to invest in doing it over again in the open, well, sure, but I don't think Oracle's going to do that. So that's the answer there. Please.
Hi. Can you please tell me how you test the new version of JDK? Like, how do you verify it works exactly as you designed? Do you have like a set of all Java programs in the world and run them?
Amongst our weapons, there are many, many ways. One of the principal ways is we publish early access builds and ask you all to help. And if you've done that, thank you very much. Please keep doing it. It is immensely helpful, but there are lots of other ways in which we test what we do.
Yeah, Mark just inverted this, and that's exactly what I was going to say.
Sorry.
There's a lot of testing actually goes on. If you follow anything that goes on in OpenJDK, you'll actually see that all bug fixes, all features, all JEPs, they're all coming with tests. If you fix a bug, then it comes with a test. There's a huge body of tests that are in OpenJDK. They're actually run all the time. They run continuously after each build. And then there's lots of other testing that goes on as well on the builds themselves. In terms of big applications, yes, it's wonderful to get as much help as possible with the early access builds to actually define issues, because a lot of the times when issues and regressions show up, they're in strange conditions that are people wouldn't have thought of originally. So any amount of testing that people can actually help, it's a great way to get involved in OpenJDK.
So to put a little bit more structure on the kinds of testing that Alan is talking about. So we have a number of distinct kinds of tests. We have the conformance tests, the JCK tests that are produced as part of the specification, reference implementation, and conformance test suite through the JCP when we make a new version of the platform specification. There are a set of conformance tests that you have to pass in order to be called Java. So there's certainly those. We have what we call quality tests. Those include the regression tests that people file with bugs, as well as tests that we write as part of development. And many, but not all of those are available in the open in the same repository as the code. We have what are called big apps tests, where we run a variety of large applications just to make sure that nothing has gone wrong. We have some stress tests, some of which run for weeks or even months for testing things like does the GC leak memory over long periods of time and things like that. So we have performance tests geared at identifying performance regressions. So there's quite a few separate test suites, each aimed at sort of a different aspect of quality, conformance, etc.
Thank you.
A follow-up question from Heinz on commercial features. Will they be available for Java 8 once they are open sourced? Well, the source code will be available if you would like to backport them to 8. Have fun. Questions up there, please.
All right, so I have a question about annotations as well. It's a bit hard to explain, so I will give you some background. Imagine we're a library like JUnit or Spring, and you want to use nullability annotations, yeah? But you don't want to force your users to have those available at compile time as well, right? So you want to make it an optional dependency. The thing is, that works fine. You don't get a compile error or even a warning for an annotation, but as soon as that annotation uses an enum constant, you will get some annoying warnings by the Java compiler. Is that actually a feature or a bug, or why is that?
So annotations are statically type checked. So I don't entirely understand what you say when you say that you can compile without the annotation type itself, right? If you write at foo1, first of all, the foo annotation type has to be available. So I don't want to be rude. A detailed question where the answer is annotations are statically type checked. I don't know how much more we can go into that. There is no optionality when a Java compiler checks both the annotation and the elements of the annotation.
Yeah, may I explain that in a bit more detail?
So we don't have a lot of time left. Maybe it's better to take this off.
There are like 5 people behind you.
All right. They don't want to ask questions, I think, but okay.
If you wish to ask a question, please go up to the microphone. Or you can try Twitter, but people at the microphone generally have priority unless something really good shows up on Twitter. All right, I'll look at Twitter then. When will Java make the semicolon optional?
The answer from the panel is never. Except in array initializers. The last, that's commas, sorry, commas.
Commas.
You can omit a comma.
Semicolons are already optional in JShell.
That's true. Speaking of JShell, with JShell being able to run instructions from files, it is now possible to use Java as a scripting language. Bad practice, or are you planning to work on making that a more viable solution? I think JShell was not intended to be a scripting language, and we've kicked some ideas around for a more viable solution that would amount to essentially defining lightweight compilation units that allowed you to write things at the top level of a source file without having to necessarily embed it in a class. or an interface. You want to say more?
Yeah, I think it's fair to say that, you can use JShell that way. We sort of view that as a bit of an abuse. That was one of the things that we, when we were designing JShell, we explicitly considered, is this a requirement? And we decided, no, this is a separate feature. I know people want it. I know it seems almost the same. But all the design decisions in JShell were made in favor of providing a good interactive experience. And those are not the same decisions we would have made if we were providing a shebang runner for Java. So if that works for you, great, but just be aware that that's not really what it was designed to do, and if it turns out not to work as well as you thought, don't be surprised. But we are thinking about other ways to get to the same place, as Mark alluded to, both at the language level and at the tooling level.
Yeah.
Boxing, will it ever disappear? Also generics of primitive types, and when?
Before the heat death of the universe.
So boxing as a language feature will certainly never go away. We're not going to be deprecating Java lang integer. But it may be possible in some future version of Java to be able to generify over primitives or value types without boxing. And this is the subject of Project Valhalla. You've probably seen us talk about this here in the past. This is a relatively large project. It's fairly deep and invasive into the guts of the VM to allow both user-definable value types, which are unboxed aggregates, and to extend the generic type system so that you can generify over such aggregates without forcing boxing. So this is definitely something that we care a lot about. We're working towards it. It's a long road to get there, so it's going to be a while, but it's certainly something we're investing in.
No, if you have a question, please go to the microphone. We're not going to repeat.
Okay. Anyway, great job with Java 9. What's next? Is it going to be a big change like Java 9 was in the future, or just a lot of small stuff? You guys relax, or were you going to tackle another big problem?
Well,
and the other question is, what is each of you's pet peeve with Java 9 that you'd like to change?
Well, so after Devoxx, we're all going on a 3-month vacation. So
cool.
Just kidding. That'd be nice. Sorry, what was the first part of your question again?
It was Java 9 was a really big change.
Right.
Do you foresee in the future another huge big change?
Never.
Or just...
There will never be another release as big as Java 9. But a related point that I'd like to reinforce, I mentioned this in the keynote yesterday, is with these more frequent releases, the intent is that the overall rate of innovation will stay the same. So if you look at Java 3 years from now, the relative delta could be about the same as from 8 to 9. Hopefully not as disruptive, but in terms of the agglomeration of new features. The main point about the 6-month cadence is the rate of opportunities to deliver innovation increases. And so then that's why there will never be something as big as 9.
Okay.
And that doesn't mean that we can't deliver a feature as big as Jigsaw or Lambda or features that would have been release drivers in past versions. We can work on big things like we just talked about Valhalla. That's a very big thing. But it's not something that's going to be the release driver for release. It's something we're going to work on, and we're going to work on it for a long time, and we're going to break it into smaller pieces, and when it's ready, the pieces can be delivered. But there won't be releases that contain as much change.
Right, and in fact, looking back at Jigsaw, Jigsaw went into 9 in 3 or 4, big steps. Each one of those steps could have been in a separate 6-month feature release with just a bit more work. So it can increase the overhead a little bit, but we don't think by too much. We have 1 minute and 30 seconds left.
Quick comment on that. So kind of the counterpoint to what Brian said about big features taking several years and going into the release when they're ready. With the more frequent releases, that's an opportunity to deliver smaller features much more frequently. And so in JDK 8 and 9, we'd put some small features in, but then those had to wait sometimes a couple years before people could use them because the whole release had to go out. And so I think one of the things that we're looking at in the core libraries is just adding small bits of API functionality here and there that people are asking for that will make people's lives incrementally better, and then that can go right into the next release.
Yep. Can I do a very quick thing? This is going to be super quick since he asked about what is a pet peeve of JDK 9. We won't have time to do one each, but I will give you one. It is the fact that the Java Beans API is still in the Java desktop module. We simply couldn't bring ourselves to force it out into its own module. So if you're using any of the Java Beans APIs, you need all of desktop.
Sorry. We actually, in an earlier Jigsaw design, we had a way of pulling it out, but it made the module system incredibly brittle and complicated. So it was one of those difficult trade-offs.
There's one. Should we take this last question?
Can we take one more? We can take one more.
Yeah, it's quite quick. It's about a syntactic sugar that, I don't know if I'm the only one who would like to have it in Java, is the safe navigation operator to prevent to do A.B that different of null, A.B.
The Elvis operator.
And I would like to see if it's foreseen, and if not, what are the reasons behind it?
It's not on our radar. It's not because we think it's an outright stupid feature, but every time we look at the list of features that we could work on, there are always more promising and worthwhile things to work on. So it just never makes the top of the list, and I suspect it won't. It's also something that is tied, it's a string that's tied to a bigger rock, which is, people say, oh, I just want the Elvis operator, but really what they want is optional types in the type system. And that's a much bigger and more invasive thing. And then they say, well, I really just want optional types, but really what they want is for all the libraries to be retrofitted to use optional types properly. So when you pull on that string, what looks like a tiny, simple syntax-only feature becomes a 100-man-year re-engineer the JDK project.
And there's also the nearby rock that some people want of, well, you should just get rid of null. Which is an interesting rock.
Yeah.
All right. With that, time is up. Thank you very much.
Thank you.